So for our next panel, I'd like to ask Captain Brian Lesko and his panel, please, to take the stage. Our next panel will discuss new entrants of UAS or RPAS, Advanced Air Mobility or AAM, and a plethora of other acronyms related to this emerging industry.
You forgot a few.
There'll be a test on this later, don't worry. Brian, over to you for the discussion. Thank you.
Thanks, Abby, I appreciate it. Good morning. Thanks for all joining us here this morning. On the discussion on UAM, AAM, and UAS. What do these terms mean to us, and how do they apply to our day-to-day lives as a line pilot? We'll dive into issues, such as how they're going to be integrated into the National Airspace System, and have a dialogue across operators and the FAA as well. My name is Brian Lesko. I am the Group Chair for the Aircraft Design and Operations Group, as well as a United 737 captain based in Washington. And it's my pleasure to moderate this panel this morning, and hope this stimulates the discussion as we go forward over the next hour. It's going to be a bit different than other panels in that we're going to take questions as we go along. So if you have a question, please come to the microphone. The lights are really bright up here, by the way, so if I don't see you standing there, just wave your arms and we'll make sure we see you. This way, we're not going to hold questions till the end, and if you're like me, you're going to forget what you're going to ask anyway. So as we talk about this, ICAO refers to remotely piloted aircraft systems as RPAS. We like that. The FAA uses the term drones, or uncrewed aircraft systems. NASA uses advanced air mobility, which includes urban air mobility as well. An uncrewed aerial system is an uncrewed aircraft and its associated elements, such as ground control stations, control links, support equipment, payloads, flight termination systems, and launch and recovery equipment. AAM includes the transportation of both people and goods at low altitudes across urban, suburban, rural, and regional markets. Aircraft electrification, hybrid designs, composite material use, and the degrees of automation technology are key components of AAM and the implementation on a marketable scale. Some AAM aircraft are designed for vertical takeoff and landing to reduce the ground infrastructure footprint and improve all operational flexibility. These aircraft would use new ground infrastructure called vertiports, and we're going to talk about that. Multiple companies are developing electric vertical takeoff and landing, such as eVTOL. To set the stage for our discussion today, in 2016, the FAA published a long-awaited 14 CFR Part 107 that governs the RPAS pilot. Now, it's a knowledge test only. There's no flight test required. And that allows you to operate the aircraft 55 pounds or less, below 400 feet, under VFR conditions, within the line of sight of the pilot. Now, the updated version of Part 107 now allows limited operations over people and conduct operations at night. Part 107 does not authorize the operations for hire. So operations of UAS, drones, RPAS, or whatever the phrase you like, outside of 107 can be operated using exemptions to the particular FARs, Part 61 or whatever. So we can see we're just at the beginning of integrating these into our national airspace system. This panel will seek to introduce and discuss leading edge technologies and integrations into the NAS. I've got such a great panel today. I'm honored to be the moderator for this panel. NASA is going to discuss their research and development for AAM, while Joby will introduce us to the development and certification efforts. Wing will highlight their automated aircraft and their plan to expand their package delivery under Part 135. And the FAA will help us understand how they're working in the new era of aviation to ensure the safe integration of these new technologies, capabilities, and aircraft into the NAS. So I also realize that I am 56 minutes and 2 seconds between you and lunch. So we will also keep that in mind as well. With that being said, I'd like to go down the line, ask the panelists to give a quick introduction, and we'll get started. Thank you.
Thank you, Brian, and thank you, Alpa. Always appreciate being here. So I'm Joe Mora. I'm with the FAA, and I am here to help. It's the old line. But no, I'm really honored to be here, and we've worked with you for many years. My normal job is the Director of the Safety and Integration Division in the FAA's UAS Integration Office. I happened to start a detail about 3 weeks ago where I've gone over to the Flight Standards Service with their leadership team to look for efficiencies and how we can still focus on drones and AAM issues over there. My quick background is my wife and I used to own a small flight school, and I was an aviation safety inspector. I'm an ATP and a flight instructor, and I stay current, and I love this stuff, so I'm going to pass off to PK.
Well, thank you. That's great background, Joe. So my name is Parimal Kopardekar, but my user-friendly name is PK. So call me PK. And I'm director at NASA Aeronautics Research Institute. I focus on advanced concepts, collaborations, partnerships, and trends such as automation, autonomy, advanced air mobility, supply chain, many other things, and what we should consider in terms of the aviation enterprise at large.
Hi, I'm Dallas Brooks. I'm the aviation regulatory lead at Wing, which is a subsidiary of Alphabet, the company that owns Google. We've been doing drone delivery since about 2013. My personal background, I'm retired Air Force, did about 26 years, retired as a lieutenant colonel. Earned my private pilot certificate in Japan over at Yokota, and I've been about 28 years ago, I suppose, since I've become commercial instrument rated, have been doing specifically drone integration issues, starting in the Pentagon for the military, and then transitioning to the civilian for about 17 years now. So I used to joke with people that if we're still trying to do this 5 years from now, that we're failing. So clearly we didn't quite get there. But it's been an incredible ride. The maturation of Part 135 operations such as Wing and some of our friendly competitors have truly gone through the roof, and looking forward to chatting a little bit about what we're doing to keep everyone safe.
Awesome, Dallas. My name is Greg Bowles. I'm going to show about a 1.5-minute video, if that can pull up now, and I'll introduce myself while that's coming up. No. So my name is Greg Bowles, and I lead the policy work at Joby Aviation. I'm a traditional aviation guy. I fly, I'm a commercial airplane pilot, commercial helicopter pilot, been flying my whole life. In the traditional aviation world, we are at a pinnacle moment. This is the electric age of aviation. So the 50s was the jet age. We're starting to see another age that's going to be additive. So the jet age will continue strong, and the electric age will kind of fit those gaps in between where we're not doing as much flying. I want to show you what we're doing at Joby really quickly here and give you a picture of that. So I think if I click this, we'll see the video start to go. There we go. So what you're looking at here is an all-electric airplane. We use a commercial pilot, and we'll talk about how we train those pilots through the conversation. But we take existing commercial pilots, either commercial airplane or commercial helicopter. This airplane has 4 seats on board in addition to the pilot. It weighs around 4,800 pounds max gross weight. We're working through this as a traditional type certified aircraft. So your gut might be like, I'm looking at a big drone. It is not. It is a type certified aircraft. It's going to be classified as a powered lift aircraft by the FAA. With the possibility of taking off vertically and landing or conventional. So what you're seeing here is some of the flight tests we're doing right now with the FAA in California. We've done several, over 1,000 test flights with these aircraft over several years. If you look very closely, some of these you'll see there is not a pilot in the seat. During experimental flight tests, we have a remote link that we can use to do some of our more risky flight tests that way. But the certified version of this aircraft will not have those remote links or the capabilities. This will always be flown by a commercial pilot. But it is pretty exciting to be able to do some of the more risky flight tests remotely. How do we fly this thing? So I'm going to walk this through with you for about 1 minute here. It's a G3000 cockpit, so a Garmin G3000 cockpit. Pretty standard stuff from the avionics standpoint, ADS-B in and out, Mode S transponder, normal navigation. We have inertial and GPS, GNSS kind of systems on board. This control is not a throttle. This is not a thrust lever. This is a speed control. So it's sprung to the middle. If you push it forward, you're going to accelerate. And when you let go, you're going to hold speed. And when you pull back, you're going to decelerate. If you let go, you're going to hold speed. This is actually a derivative of the flight controls in the F-35B. So that is an airplane that can also perform vertically And they developed over 30 years a really wonderful set of flight controls that's now utilized in that aircraft out of the learnings of the Harrier program. And we've kind of taken that and a step further. So speed-wise, this is a speed lever. So what's interesting about that is if I pull the nose up, normally I'd have to add some thrust to stay at speed, right? Well, if you selected 150 knots by kind of holding the lever forward until the number said 150, when you let go, you're kind of holding that speed. If you pull the nose back, you're going to climb at 150. If you level off, you're going to level off at 150, and if you dive, you're going to dive at 150. If you'd like to change that speed, you can. You have flexibility to do that. In fact, if you hold that speed lever back when you're flying on the wing, it'll come to 0, and it'll start to back up. It's very straightforward. Now, the fly-by-wire system takes care of all of the articulation of the propellers, the motor RPM. In failures, the controls are the same. They present themselves the same even in failures, which is a pretty good thing. Let me show you one of these other controls here. This is the vertical rate control. So if I'm flying around with some speed and I'm on the wing, this is just like a normal airplane. So when I pull back, the nose goes up. When I push forward, the nose goes down. And if you let go, it's going to hold that attitude that you set. So, so you're kind of setting a attitude, a pitch attitude when you're moving that. Now, if we come to 0 and we're hovering in the sky and I pull back, the airplane just goes straight up. And if I let go, it will stop. And if I push forward, it goes straight down. If I let go, it will stop. So in fact, you can do a vertical takeoff with no speed by just grabbing that control and pulling back, and the airplane goes straight up in the air. And then you can add some speed and get under the wing. We can talk through some other fun logistics, but you can sit in the transition, you can go on either side of the transition. It's seamless to the pilot.
And in fact, I think that's a great transition into comparing the technologies for manned crewed aircraft and uncrewed aircraft. Also have about a 3-minute with audio to talk a little bit of how Wing does drone delivery at scale.
You want to share yours? Yeah, there you go.
Thank you. Wing is the realization of what people have been thinking about and talking about in terms of using drones for something beneficial for at least the last 15 years. I've been in this industry for 17 now, I think. So for almost all of that time, people have talked about, what if I could get what I needed delivered to my door in minutes? That has always been the what if of maybe next century we'll get that, or maybe the next couple of decades we'll get that. Wing is that, and Wing is not the idea of that. It is not a project to do that. Wing is that today, which is one of the reasons that I was so excited to join this company when I did. We're currently delivering thousands of packages to homes around the world. I think we've recently crossed the threshold of over 220,000 commercial deliveries and well over 300,000 total flights, because we do a lot of flights for other reasons that are not delivery, such as tests and evaluation and things like that. Our system and our model is incredibly simple, as you might expect from companies like us, and it's simply on your phone, like any other app. You can shop on your phone, you can tap on those products that are in the library as deliverable, you can pay for them like you ordinarily would pay for them, and hit go, and the rest of it happens automatically. And quite frankly, there's very little times that a human needs to touch either the aircraft or the package. Once that package is loaded, a drone takes off, hovers, accepts the load, flies to your house, gently lowers it to the ground in your yard or in your driveway or wherever you select it, and leaves it there for you to retrieve safely. The airplane never touches down. It never touches so much as a blade of grass in your yard. It always stays well away from dogs and children and anything else. And it's an extraordinarily light airplane. It's essentially about 10 pounds of primarily styrofoam. So it doesn't present anything in terms of real danger to people or property. We spent a lot of time thinking about how to do this right. And the realization is all those successful deliveries, zero impact to safety. I think our safety record speaks for itself. So all that convenience, all the safety that you would demand from that convenience, all happening at once in the world's simplest interface that lives in your pocket. That's Wing.
All right, well, that's kind of hard to follow. Hi guys, my name is Vaslav Patterson. Everyone calls me Vas. I am a United Airlines 737 pilot. I work with Brian quite closely. We are part of the Air Safety Organization, ADO Group. I do the drone stuff. I'm the director of UAS. So I'm usually talking to most of these guys, trying to figure out how we're going to integrate this process into our airspace system safely. I won't take up too much more time, and we'll just go right into what Brian has.
There we go. So thanks, guys. I'm really glad. We're going to be looking at current technology, new technology, and PK is going to give us a view of what's down the road. So I want to tee this first question off to Dallas and Greg and also to Joe a little bit here. As far as the certification and testing, right? So how is the certification going? What issues, lessons learned can you guys share with us during the developmental process to get airworthiness? And also to Joe on that part, or how is the certification going under 2117 Part B to look at that, and how is that working, and how are the FAA and industry working to get these aircraft certified? So whoever wants to tee it off first, maybe Greg, if you want to start, or Dallas, or one of the two. What does it look like for you guys? What have you learned, lessons learned? Where are things now versus when you first started? And then to Joe, how is that playing into your side?
So I've been involved in the classic aircraft certification world for a long time. I have a heritage working at Cessna Aircraft Company, designing business jets and bringing them through certification at Sikorsky. And so we actually have been following a pretty traditional certification process where we work with FAA to set up a certification basis, the rules that apply to us. We then kind of define the tests that we're going to do, and then we execute those tests with FAA oversight. And so that's where we are in the process. We're going through that process, proving out the safety of the aircraft. I'm sure a lot of people have questions. What about battery safety? What about a motor going out? So absolutely all those issues need to be addressed and are addressed by the certification. Environmental questions. So great conversation if someone wants to ask a specific one, but that is part of the certification.
Our type certification process on the uncrewed side is a little bit different because there's more to certify than just the aircraft itself, right? So the FAA has chosen to sort of divide that certification into certification of the aircraft and certification into what we call associated elements. And that's the things like the ground control station and the software that it runs. Communications links to the aircraft, right? Those are the kinds of things. And they're essentially intended to be run in parallel. Right now the aircraft is running a little ahead. So Wing has completed its certification basis for our aircraft. FAA's finalized that. It's actually getting published in the Federal Register in the next week or two. And then we expect to receive that certification probably on the order of between the next 1 and 2 months on the aircraft. The associated elements process is new for everyone. We're working with the FAA on basically how we benchmark that, what we as a manufacturer and an operator, how we've made that dividing line between the aircraft and the associated elements, and the appropriate benchmarks and thresholds to say that's sufficient for safety. That's a brand new area for the FAA. The certification on the aircraft side is being done by the folks you know and love on Aircraft Cert, and the certification of associated elements is actually being done by our friends in Flight Standards. So it's a little bit of a bifurcated process, but it's going well. Matternet, one of our friends, just received their type certificate last week, and like I said, we expect to be right behind them by about a month or so.
So yeah, I'll add on here for Greg and Joby, when you talk about the advanced air mobility and what you're doing, on a safety continuum, exactly what Greg said, that's going through the same rigor as any other passenger carrying aircraft, and the fact that you're bringing it in with a pilot to start with, or inevitably for the beginning, it really makes it no different than certifying any kind of other aircraft with a just new form of propulsion. That being said, there are some really good benefits that are coming to that, and Greg mentioned it too. The envelope testing, the flight testing, the fact that you can do that remote, and the fact that you've got companies that are designing these from the beginning with the ability to fly both manned and unmanned is really bringing some unique technological answers to the table here, and the testing going through it is fascinating. So that's pretty much on the high end of the continuum. Now, Dallas said it is a little bit more challenging, and it is when you're talking about a 10-pound foam UAS. Now, they have lots of redundancy. But the aircraft actually flows into a lot of different things that we look at the same time, because we basically, where you have a traditional sense of if you want to produce a new aircraft, you go through the aircraft certification process. If you want to get access to airspace, that's a pretty well-designed air traffic way of doing that. If you want to be able to operate or become an air carrier, that's pretty well-defined. We have to kind of look at all three of those right now at the same time. So as Dallas said, you can have our aircraft certification division look at just the aircraft, but all the other associated elements that go with that are now falling over into the flight standards side. So once again, on a risk continuum, you're talking, minutes worth of flight, you're talking much less kinetic energy, and you're talking a whole bunch of operational mitigations that we have to bring into the mix of this. And as Dallas said, it's getting interesting because UPS Flight Forward, working with Matternet, Matternet just got their first type certificate for UAS just last week. So we are learning, and a lot of those associated element issues right now are being addressed, as Brian said, in exemptions and waivers in those areas that we can do while we're learning to build better rules.
So under 2117, what have you learned in the rulemaking process as the evolution obviously now is different than it was 2 and 3 years ago? What are some takeaways that you have seen? And I have a follow-on to PK here in just a second, but what are some things that you've learned in the process that maybe now or you look at it a little bit differently than you did 2 and 3 years ago?
Obviously, the powered lift discussion comes into it, and how, whether the basis is going to be, as Greg said, under 2117B, or what you do a traditional under 2117A. And the main takeaway with this is nothing has really changed of the way that we look at how you certificate. You're still asking the same questions. You're still asking essentially the reliability. It's just a lot of these vehicles did not fit comfortably into being either an aircraft or airplane or rotorcraft. So you have to actually take a step back and just get to the fundamental questions you're asking. And when you do that, and when you go to a higher level, many of the safety issues, many of the questions are the same. So I don't think it's really presenting challenges as much as us trying to make the process repeatable and understandable, and whatever we need to do rulemaking-wise to codify that and make it normalized.
Dallas or Greg, any thoughts or
Yeah.
PK as well as for you?
Yeah, certainly. So we started our journey into the small drones in almost 10 years ago, and I'll add a different dimension to the certification and operational characterization. Is how do we integrate these in the airspace? That is a fundamental question. We have drones. FAA's forecast is expecting drones in the order of millions as compared with current aviation that has 50,000 operations. So the idea is to scale these operations without overloading the air traffic control system. How do we do that? So we flipped the model from management by clearance to something we call management by exception, by digitizing trajectories and creating share and care environment where with application protocol interfaces, which is standardized protocols for sharing trajectory information to each other. So what controllers see on the display, basically we are digitizing that and sending that information to the operators. And their operators then know where the other aircraft are, drones particularly, and then they can stay away from each other. So that's the idea of this flipping the model towards management by exception, by digitizing, by sharing the intent, and creating this environment. The other dimension we added is third-party service and service-oriented architecture that allows the industry's best capabilities to offer services for flight planning, tracking, communication, navigation, surveillance, and so on and so forth. So that allows us, again, to get to that point of getting the best technologies to help integrate the airspace. This all happens under the regulatory authority of FAA, obviously, and we have seen examples of that under low-altitude authorization notification capability that FAA has already implemented. So that was the lesson we learned through series of flight tests and campaigns over 5-6 years working with close industry members like Dallas, Google, Amazon, and several others. Fast forward to advanced air mobility, we said, okay, this model really works of collaborative innovation. Work closely with FAA, work closely with industry and members of your community, and then let's look at how we can expand that to advanced air mobility. Advanced air mobility, then we have a few more things we added. One is the noise. We need to make sure that the noise is acceptable by the communities, the safety of the operation, so we have methods to assure the safety of the performance of the vehicle.
It's interesting you say about the noise piece, because that obviously is a primary concern as the proliferation of these aircraft come across. More maybe for Joby and Greg. What standards are you looking to meet or expected to perform, or what level of acceptability within the public? You know, because obviously you hear the airport issues, right? And you have that ad column, right, where you own that piece of airspace to the sky, right? So what are you seeing in that side?
Yeah, it's a very important subject. So we touched on the safety piece. Historically, that is the most important thing, right? We really, really care about safety. And then as aircraft designers in the past, we've kind of prioritized fuel efficiency and some other things. What's interesting about some of the advanced air mobility design is noise racks really, really high. The goal is to be able to eventually have more aviation available into more of those airports that are underutilized and more of those helipads that aren't utilized. And so you have to be quiet to start to do that. One of the really cool things about electric motors is they make a huge amount of torque at low RPM. So maybe there's a couple Tesla drivers in the room. When you touch that pedal, you have instant torque. Well, that translates in a really cool way to aviation. So it means we can turn those propellers really slow. We can make flight torque. And in fact, if you look at the numbers, we've got some cool, NASA helped us measure this to be an independent third party. And so we're about 1,000 times less acoustic energy in our hover than compared to a helicopter. And that's us at our loudest. When we're on the wing, we're below 45 decibels, which is basically silent. So really, really cool what you can do with electric and noise.
That's interesting. So I want to, most of you who know me, I tend to ping pong thoughts. So it's not going to be a surprise. I'm going to change a couple of things here just a little bit. But you mentioned using the pilot for certification and things like that. And this is going to be a question for really all of you and down to Vass is how are you going to use the pilot, and more for Vass, what are we advocating, or are we advocating for pilot training and certification and standards, and what does that look like to you guys?
So to answer your question, yes, we are advocating for that. I think pilot training and pilot certification are a critical part of the safety continuum, as Joe mentioned. Having training, as many of you know, and pilots here, training is a critical part of what we do. And
you're about to go do it here very shortly. So.
Exactly.
Congratulations is out to Vass, by the way, as he's going through Captain Upgrade here very shortly. So.
Thank you. So it's a critical part of what we do. It's a part of the SMS process. We figure out stuff that we're weak in, stuff that we need to build on, and we go through and we fix that and create training profiles to address those issues. Brian mentioned earlier in the conversation that there's Part 107 that's out there that is just a test process. So as we go through this integration process and we have these different sizes of aircraft, different weight, different classes, we're going to need to address training and the fact that people are going to need to demonstrate that they're capable of operating these things, especially when we start talking about beyond visual line of sight, how that works. Not all operators will be large-scale operators that can have the technology to basically be autonomous, but you're going to have people who are building businesses, and they're going to need to prove their skills, and have a training process to continue to build on the safety. Because what we don't want is a regression in safety as we introduce new equipment to the airspace. We want to continue to build on what we have and make it better. So through technology, we have different things coming from a technology standpoint, but definitely training should be first and foremost and front and center to the process.
I was just going to add to that, and a thank you to Alpa and Vass and Mark Reed too, because the FAA is kind of unique too. When we contemplate what the future will look like through rules, we're one of the only organizations that can do an aviation rulemaking committee. So we put together a group of 89 industry stakeholders, and Alpa was part of that. And we had Dallas was in the same group with us talking operator qualification. So was Vass and Mark. So it's a really interesting one. And as you bring up with Part 107, we looked across the all the different levels of certificates, and once again we looked at the risk. People out there operating right now at a very basic level within visual line of sight, below 400 feet, not in controlled airspace, during the day, what is the acceptable level of safety. So that's kind of how we targeted that one, and I think so far, the compliance with 107 and the people operating under Part 107 don't just seem to be an issue. So we've actually embraced a whole group of people that are now, I think the last number is approaching 300,000 remote pilots. So that's quite a bit, and it's over 800,000 registered drones. So definitely we're looking at that, but to Vass's point also, as you get more advanced and as you get larger too, it becomes more of the type that you're flying. So we're looking at that too, like what, obviously to fly Joby's aircraft, there's training and there's probably going to be, we can do that through experimental certificates right now with restrictions, and we can do that with what we require of their pilots. But definitely in the future, as all of you fly, if you transition to a new aircraft, and that's where we have to hit the sweet spot of what do we do as a regulator to require, and then what does the operator require? Because I know we were discussing even before this panel the whole one-to-many question. And,
Yeah, I was going to get to that here in just a quick
take
sec.
that
Yeah, without a doubt, there's the elephant.
Yeah.
But I did want to get, sort of Greg and Dallas's thoughts on what their training would look like. Is it being developed?
No, it's
What do you guys
hugely
consider?
different because the way that we fly, so pilots do not operationally control our aircraft, right? So our operations are extraordinarily automated. As I mentioned in the video, from the time we set the airplanes on the charging pad at the beginning of the day and the time we retrieve them at the end of the day, a human being may never touch that aircraft, and a human being may never almost never would actively control that aircraft. Our routing is done automatically, our deconfliction is done automatically, our altitude selection automatically. Obviously we're monitoring the airspace for other traffic. All those sorts of things are happening automatically. And this allows us to do drone deliveries at scale. This allows us to conduct thousands of operations a day like we do in Australia right now. And so while we are required to have PICs under the FARs, our PICs are largely monitors. And they monitor essentially areas, more like an air traffic controller than a pilot, because their sole action is one of intervention. And that intervention is to command an automated process yet again. Our pilots can draw a box on a screen encapsulating a certain number of our drones and command them to land. Those drones will select an area that are away from populations, roads, structures, et cetera, gently set themselves down and wait to be retrieved. So in that case, we'll get to the one-to-many in a bit, but the role of the pilot is extraordinarily different. The level of training has to be tailored to what the pilot actually does, right? So in terms of how we train our pilots, obviously they get all the fundamentals that you would expect them to get, on weather and air traffic and et cetera. A lot of our pilots also get visual observer training if that's needed, but at the core, the functions that they perform are within the scope of the automation system that they work. Much as the core functions that any of you perform on your associated flight decks, right, are related to the systems that are in front of you and what you need to be qualified on and what you're not. So there are extraordinarily large variations in the amount of automation and reliability and testing put behind that automation for a Part 135 certificated carrier such as Wing versus someone just operating in a drone. And to Vaz's point, we have to make sure we capture that entire spectrum, right, when we're looking at who might be operating and what the appropriate level of training is.
Well, so PK has a thought on that, and I want to get Greg's comment on what training would look like for that particular aircraft as well. So you want to dive into that, and then I'll get Greg, and then we can talk about your...
Yeah, I was just going to add that uncrewed is a little bit of a misnomer because there is a crew somewhere. It may be on the loop, it may not be in the loop, and all those subtleties. But really, it's a risk-based approach that we tend to promote. And I'll give you an example. Wildfires on the Western Hemisphere right now is a big problem. During the wildfires, what happens today is that firefighting happens through aerial means. The air boss or tactical air group's supervisor is watching basically aircraft, fixed wing and helicopters, and then controlling traffic, managing traffic inside TFR or fire traffic area. That stuff stops as soon as the smokestack shows up or the visibility goes down. As a result, you fight fires 4 to 6 hours a day through aerial means. The last year's top 5 fires lasted over 2 months each, costed $1.8 billion. So that tells us there is an opportunity space for us to use these automated systems, remotely operated drones outfitted with retardant and water and conducted through or managed, the trajectories managed through a small unmanned aircraft system, traffic management in a box that allows you to plan trajectories, deconflict strategically, track them, and show that you can actually continue to fight fires 24 hours a day. That's a tremendously beneficial use case for many types of emergencies. But that allows us to sort of test the technologies in a way that we can be somewhat assured that these things are practical.
And we'll dive into one-to-many, but I want to get Greg's thoughts a little bit since we're all pilots on the stage here. What does your training look like for that aircraft? And there's so many different variants, right? You've got brand Y, you've got manufacturer X, and this type of stuff. And this might dovetail back into the FAA a little bit, is how do you regulate that? But what does it look like, and what are you advocating for as you put the pilots in there to fly this aircraft?
So this is actually a great panel because we're looking at a spectrum of things, right? We talked about this, weighing on one side of the spectrum with a very small inert aircraft that's built to bump around and be safe. Ours on the other end of the spectrum, human carriage, top level of safety. And so what we're doing is actually taking existing commercial airplane, existing commercial helicopter pilots. They take a type rating course, very traditional type rating kind of training, and then they get approved to fly on an air carrier certificate, fly the aircraft commercially. So very straightforward, fits into the existing system kind of pilot training with all the recurrence and regulation. What you're actually doing is the pilot is very similar. You have a little bit more ability to focus on some of the high-minded pilot skills because hands-off is actually kind of safe in this aircraft. It doesn't need to be kept shiny side up as hand and eye as we do helicopters.
And particularly, we've heard in certain situations where there's so much autonomy and so much automation in these aircraft that will design and training providers will take that credit for the level of automation in their training program. Do you see that as something that's coming down the pike, or?
That is actually built into the Aviation Rulemaking Committee recommendations, that the level of automation, and we've quantified those into specific levels and defined what those are, that does impact the amount and type of training that you need to fly that system.
Excellent. So I do want to get into that one-to-many, right? So we've talked about, one pilot to amount of drones. How, and this might be a PK question or to you, how many are currently at, Wing are we looking at as far as how many are an operator or a pilot controlling at one given time? And, maybe can elaborate and share some of the human factors as to
that's
attention
great
tunneling and
question.
things like that.
Yeah, I don't think we have a clear answer. I mean, there are hypotheses about it, and there are basically business needs or business cases that say 1 to 1,000. So on one scale, Intel has done 1 to thousands, really small drones, which have almost zero risk of hurting anybody, right? So those type of things on one extreme, and other extreme, the larger and bigger
drone
aircraft.
light shows.
Yeah, the light shows.
Right.
Yeah. So that's one extreme, and then other side is people carrying things. And we really are still studying, how that one-to-many would work. I think the business cases are really some place where we need to identify the risk. It remains the same, and keep on adding basically the ratio of M to N, what we call M number of vehicles and N number of basically supervisors.
Tell us, what about your operation? Can you elaborate a little bit on how many are?
Oh, sure. Yeah, we're currently doing more than 1 to 20 in Australia right now. We're doing more around 1 to 8, I believe, in the U.S., and that's mainly just because we're still walking through the wickets with the FAA. There is a process for us to prove each higher level of one-to-many capability, and so as we walk through that, but our system is capable of well into the 1 to the hundreds, and that's with no degradation in safety or operational capability.
And then human factors considerations and things like
Yes,
that
because
as
the
well,
paradigm
or-
changes, right? So, and this is also in the Aviation Rulemaking Committee, because you get away from the notion of a PIC and more into a supervisor of an area. And that supervisor of an area is maintaining SA and what's going on across that particular assigned area. And exception management, those functions are also highly automated, but alerted. The coordination you need to do, similar again to air traffic controllers with adjoining areas. In the case of, say, let's say you have a presidential movement or something of that nature that needs you to freeze operations for a while. But yeah, the entire paradigm changes. And so it's more of a supervisory monitoring function. And the level of automation and robustness of that automation and level of validation and testing of that automation allows us to achieve those numbers safely.
And if I could just add, from the regulator's standpoint, Wing was the first company to come through and actually receive a Part 135 air operator certificate. But they started with a single pilot. They worked their way up to standard. So between their manuals, their curriculum, proving flights, just like Dallas said, we don't approve 1 to hundreds. They have to demonstrate any multiples that they're doing. So they do go through quite a bit of rigor. And this is kind of an operations first mentality here too, because we don't necessarily have the regulation structure that fits this perfectly yet. But by doing this through exemptions and waivers and authorizations, we're actually learning a lot more about where the industry wants to go and how the safety gets cranked up as you work up that continuum too. So it's a really good experience for us to do that, and that's why Dallas said it's actually your overseas operations are helping that too, because you're coming in with a lot of testing hours from other places. And now there's 3 other air carriers out there too: UPS Flight Forward, Amazon, and Zipline, and very similar, well, different operations, but similar approaches, and the rigor is still the same. They're air operators, air carriers.
What
So,
about
Brian?
Go ahead.
So I think as this process continues and companies like Wing grows, the sharing of data will kind of show what happens with so many airplanes being controlled by one individual or 2 individuals. So as time goes, I think that's going to be critical, is for that information to start coming to the forefront. I know now it's kind of proprietary, but as you grow, that information should be shared so we could actually determine what is the appropriate level.
Well, and that's the other part too. We're a very data-driven industry, right? Mm-hmm. And it's been that way for a very long time, and that's why we have the safety record that we have within aviation. So I think that's a very valid point to ensure that there's a data method to be able to do that, because everything we do is data driven, right? So absolutely, that's a super important point. I do want to look at it, and we hear often that UAM, AAM, and the package delivery operates at scale, right? So you ramp that up, right? So what does that mean to you guys, and where do you see that going forward, and timeline wise? We hear AAM, and there's certain countries that are planning to operate AAM in Paris for the Olympics, and they're going to be ready in 2024. What does that look like to you all in terms of at scale and exponential and ramping up? What are your thoughts?
So the 2 key things that we need in place to operate our aircraft safely, at Joby, we're manufacturing, designing, certifying the aircraft. We're also the commercial operator. So the 135 operation, we actually stood up a clean sheet 135 that's now in place, operating traditional Cirruses and smaller aircraft, so that over time we can add this aircraft onto that certificate. The new aircraft can be added onto that certificate and start to operate in kind of the crawl, walk, run kind of path forward. We began FAA certification in 2018. We intend to be in commercial operations in the 2024 timeframe. Right now, we're actually operating aircraft with the U.S. Air Force and other branches. We have some great contracts that let us have, we have airworthiness with the Air Force, and we continue to kind of grow that portfolio. It's a great opportunity to learn the robustness, reliability, and the maintenance of the aircraft. So it is happening. We are living in the world of electric aviation at this point. Yeah.
Package delivery by nature, as you all know, is a volume business, right? You don't do well doing boutique delivery of packages over a long period of time. So you have to be able to scale that. And one of the most important reasons to scale that, and this is one of the reasons why Alphabet got into the drone delivery business to start, is the impact that that has on our society. So for the thousands of packages that you're delivering that last mile to homes and businesses across a metro area, you're taking delivery trucks off the road. You're taking people having to get in their car and drive to Walgreens or a big box store to buy something, taking those people off the road, not just the emissions, but the risks that they're taking, because a certain percentage of those folks will have accidents, and a certain percentage of those folks may die as a result of those accidents. And so far beyond the amazing carbon footprint advantages of electric propulsion, we've got this tremendous opportunity to take people out of harm's way. And that's one of the biggest drivers for our philosophy of why this is a good thing to do. Doing that at scale, obviously, we're operating today, for example, in the Dallas-Fort Worth metro area out of a couple of locations, 3 locations, expanding that over the next year. And the results that we're starting to see in terms of the demand for the service, we're growing it very deliberately on purpose because we want to be very, very good neighbors, allow folks to get used to the idea. We've developed a newer aircraft that's being paralleled through our type certification process that reduces noise by another 10 dB, even though it was already 10 dB quieter than it needed to be. So we're taking all those things in consideration because scale doesn't matter if you end up making people mad, right? Scale only matters if it's convenient, it doesn't impact their lives in a negative way, and in fact, in a lot of ways, it impacts their lives in ways that they didn't even think of. Having that package at your door within minutes of when you need it, and doing so with less risk, less pollution, more convenience, that's really what it's all about. And quite frankly, one of our biggest challenges is controlling our growth, because demand, once we begin to operate in an area, the demand tends to go nuts.
And I know PK has a follow-up on that, but I also ask Joe, on the end of that is, what does that growth look like as far as regulating that growth?
Yeah,
To make sure that you don't grow so fast that you go beyond your means, right?
Yeah, so the part of scalability is they want to scale, these guys want to scale, and many other operators want to scale. And what I get excited about is how do I put all of them together in the same airspace at the same time?
Sure.
Trying to make everybody to interoperate and be safe and efficient and give everybody the best possible, basically, trajectories that they would like to see. And that's really fascinating. I mean, air traffic management, airspace operations, and automating it to the point where it can scale these operations, one. So part of that scalability. And the second part of scalability is making sure that we have supply chain and maintenance that is available. These guys are going to operate at regional, local level, so we are going to need maintenance and parts inventory and supply chain at the local, regional level. That is different than what happens today, which is an exciting opportunity for businesses. So.
Good.
And I've got one question about the podium over there, so please, go ahead. We've got 7 minutes left, so there is an opportunity to engage here, and I will not hold you between lunch, but please, go ahead with your question.
Hi, guys. Great presentation. I'm Brian Moynihan, Alaska Airlines.
I can't even see you over there, Brian. If I knew it was you, I wouldn't have called on you, but go ahead.
So I think this has been a fantastic presentation so far. I'm really impressed with a lot of the advancements and the new potential. But one of the things that, as a airline pilot flying in the NAS, that I'm more interested than even the potential upsides are also the potential threats and risks. And actually, the Delta ASL for LAX, Jason Herman brought to my attention just recently a new system that the FAA is using called DTI, Detect, Track, and Identify, in Miami and in LA, especially with LA, where you have literally people flying through the airspace like on a wingsuit and stuff.
Yeah, Jetman.
Yeah. Why I'm asking you this question is everything that I have read about DTI, which is an exciting technology, right now it is limited just to detecting, tracking, identifying, and that's it. And where I'm most interested in is deterrence. What I'm very interested in is finding, that's good that we see the threats moving around us, and I'm interested in finding ways we can use that technology to deter and keep errant drones out of the airspace that I fly in.
Do you want to comment on some counter UAS? Or?
No, I'm happy to take that question, and it's good that you're up to speed on all these things, because it's, number one, we want to embrace a culture and bring responsible aviators in. So when you're talking about detection of errant drones, I think that falls on the spectrum of, it's probably not your air carriers, it's probably not your certificated operators, it's the ones that, so what are we doing about that? We have a remote identification rule that's going to be feeding into that too. So the manufacturing compliance date is actually tomorrow, and we're using some, there's some stuff on the website that's going to be some legal discretion to allow manufacturers up till December 16th to implement that, but that's a digital license plate. So the rule requires that you have to be broadcasting certain information, and that will actually go operationally in effect a year from now. The next thing about mitigating, we work with our security partners on that. So the FAA does not currently mitigate those things, but the remote ID fits into that, because what you have to do fundamentally is you have to know something about the intent of the operators out there. So if an operator is known and that serial number actually tells you something about them, your threat level is probably lower. If somebody's not even emitting a remote ID signal, that can get your level up a little bit higher. But honestly, we're trying to embrace and create an environment where people understand that you're sharing the sky as a natural resource with all other aircraft. So by enabling safe operations, we do believe that that builds up the culture.
PK, thoughts?
Yeah, this is where the unmanned aircraft system traffic management really comes in handy, because you are creating that share and care environment where trajectories are shared, and there is a discovery synchronization process that allows all the entities to say, hey, who are these operators who are authorized to operate in these airspace? And if you detect someone that is not in that UTM system, then you have two things to say about it. One is, oh, was it in the UTM system and the trajectory was X and now become a flyaway, as he was saying, so that's a trajectory Y, that's a different problem. And the second one is, it just never was in the UTM system, so it was never a friend to begin with, so now we need to do something about it. So I think this is why the more operators that are cooperative, that allows us to find the uncooperative very quickly.
And there's some counter UAS things out there that Vass and I have seen through our work, and we're planning from the ALPA perspective.
Yeah, and I'll just talk on that too. So right now, they're aircraft, so you can't really interfere with an aircraft in flight. So as we develop and things get better, and we start identifying them, and there's a license plate, and then we know where they are and where they're coming from, we're better capable of identifying where the actual threat is and who is an actual threat, and then we could possibly take action at that point. But yes, the concern is still there, and we are going to have people who are just not going to cooperate, but then their drones will be taken out of service.
Thanks, that's a great answer. And then I'll just leave with a statement. I think one of the things that ALPA does amazingly well for the safety organization is the other side of the house, where their advocacy, and I might just recommend, if we have systems that they've already are deploying that detect, track, and identify, and right now I find no teeth legislatively that actually allows us to do something about it. That might also be another avenue that ALPA on the legislative side might be able to help us out. That's all.
Thanks, Brian. I've got John McFadden standing there. If you got a quick second, we can do that. But I've got about a minute and a half left. So I saw John, you standing there. I'll take one more, and then we got to wrap it up.
First off, thanks, Brian. I appreciate it. Thanks for the panel's work. I'll make it really fast. That was a great video of the box of cookies being picked up and carried and dropped off. What happens if that box of cookies is not quite so innocent? You've talked about how you have control over the unmanned or drones and the security we have in place. What about that package that's picked up? How do we prevent that from being something that would be bad, that would harm folks?
Well, in our current operations, those packages are loaded at wing facilities, right? As we expand to where we're doing pickup and drop off at facilities, around the metro area, for example, then those controls have to be put in place, and we're designing those now that ensure that whatever goes into that box, has an appropriate chain of custody, right?
Well, you also have a will carry hazmat program.
Absolutely.
Yeah.
So there's lots, we're talking about the difference, I think, here to distinguish the nuances of your question between the possibility of a bad actor versus just the possibility of the wrong thing being carried to the wrong
And
house.
some of these guys will be around here as well for lunch. So I have 6 seconds left. I can't believe we got it done in an hour. I have 35 more questions I can go through, but thank you all for your participation. Thank you to this all-star panel, and thank you for being here this morning.